everybody, and good evening. So basically, without further ado, we'll start looking into what the presentation is about. So I'll be presenting the first part of the presentation, which is describing the architectural pattern around reducing complexity. So I'll describe that in more detail in a bit. And then after that, it'll be Luis who will be helping us understand some of the key features of Redis that can be applied or are relevant to this kind of architecture. We'll keep these two parts hopefully fairly brief, and then we'll follow up with a QA session, which will, there are a few questions that we have ourselves that we think that could be relevant for people, but also we'll be welcoming people to ask questions around the architectural pattern itself, how that may be applied and how we have applied it, and also the features of Redis that are relevant to this as well. Right? So let's get started. So before I look at the architectural pattern, the pattern is part of the strategies that we apply as in our software modernization service. So we help our clients stop the rot basically in their software and in their software capability. And the idea is to continuously evolve and help the clients to evolve their systems so they can increase the business agility and they can become strategic and an engine for growth of the business and a great system for the users as well. We have a few links if you want to know more about what software modernization means in a very holistic sense. We have a few links that will be in the chat, and we also have a tool that asks a series of questions to help you understand where your software capability is and where your systems are and the areas of weaknesses and strengths. So if you're more interested, just have a look at the links on the chat that will be shared. Right. So in terms of modernizing software and reducing the architectural complexity in investment banks, there are many drivers. These are some of them. I'm sure they are not news to you. In particular, the regulation is becoming stronger and stronger, and we're having to think about our systems in a very different light to be able to comply to those organizations. There are regulations around reporting, but also around providing open systems for open markets and those kind of things. And of course, risk, business intelligence, cost, competition, these have always been there. Competition is fierce in the investment banking world, and no investment bank can afford to stand still for too long. And now the innovation is another super important part, and as you can imagine, the fintechs, the startup fintechs are actually stealing a march in that area. And again, the larger banks have no choice but to start innovating faster and to keep up with the speed of the much smaller, more agile organizations. So I won't go too much into this, but this is the background. So there is no choice but to improve the way our software, our systems are working and are built within the financial industry. So to give you a bit for context, the scale of the problem, from my own experience, you see that there are many silos within the investment bank, right? So you've got this kind of the front, middle, and back office divide, right? And then you also have all the different types of trading that happens, right? Then you also have a lot of different departments like business development, production services, operations. You have teams that are primarily concerned with enterprise architecture, group CTOs, all those kind of things. And adding to that complexity, you have these regional divisions as well. And you got things like banks in a box and segregation of duties, and all these things are effectively creating silos from many dimensions. And what happens is that within each one of those kind of combination, you end up with a system. So the Conway's law is brutal in this case because you end up with many, many systems. In UBS alone, we had over 200 trade capture systems, right? And so the complexity is absolutely huge when you look at it from a holistic point of view. When you look at all the organizational systems, especially when it comes to trading, as one thing or as an overall thing, and how they interact with each other, it is very complex indeed. Taking just the types of systems, and these are few of the types of systems that are available or that you have within the investment banking world, right? You have more as well. But just taking those and just kind of in a very simplistic way, linking them up, you can always already see the mess that you have, or the complexity that you have. On top of that, each one of these is a type, not an instance. So there are many instances of those, as I was mentioning earlier. So what you have is effectively a great big forest of these systems talking to each other in a lot of cases in a very much for point-to-point way. And this is the problem. These systems have evolved organically, and they've come up, and as the need for these systems to talk to each other has arose, they were local decisions made for them to share the data. So not just how the data is shared, but also the data itself is very much related to what the other system needs. So they are quite coupled with each other. And we use a myriad of technologies underneath for them to speak to each other. Like the most common is message brokers and queues and so on. But you have file transfers, you have ETL jobs from database to database, you have web services and all these, and database syncs, and all these things are being used in many different ways for these systems to actually talk to each other, right? So effectively, what you have is kind of this communication between these systems that is actually quite unreliable. So I'll go into that in more detail, but normally even just taking messaging, for example, when one system sends a message to another system, there is normally no acknowledgement of those, and there's no records kept of what was sent, and even on the other side, a record of what was received. And as the message is passed, it's ephemeral. It goes away. So you've lost that kind of fact that happened in this world, and then you rely on these systems to be able to kind of handle that, to kind of make sure that they are a good keeper of those facts, right? And it's all fragmented, as I said. The way the systems are connected to each other is very point to point. It's not a case of like, when something happens, an event happens, what's the complete information that I need to broadcast? It's more about what that other system actually needs, right? And therein is the coupling as well. I will mention the coupling aspect in a bit more detail as well later on. But as you can imagine, the way that these systems are talking to each other, it's been built over time, and it's not really fit for purpose. And moving on to the things that we were talking about around observability, that is becoming more and more important, around data that's becoming more and more important within the organizations, right? This is not the way to go, right? So kind of zooming in a little, this is a typical kind of architecture that you see in investment banks, right? You have messages, point-to-point messages going on through queues or message brokers, right? And as I said earlier, there's normally no acknowledgement of those messages. So what happens is that sometimes a message is sent, it may get lost somewhere, and even if you can guarantee delivery to the receiver, what the receiver does often is not the first thing. It is to actually, the common sense says that you save that message, you store, and then move forward. Often that doesn't happen, right? So if something goes wrong, right, there might be a silent failure, there might be some sort of an error, the message goes into some kind of an error queue, no one really looks at it, and all those kind of things happen. And so what starts happening is there's a break in the process, but there's no real way of understanding what the breaks were. You can go to these exception management systems that they have and so on, but again, they are so complex, but you don't have a really good view on where those breaks are. And especially in real time, right? So what normally happens is you build another system on top of that called the reconciliation, right? And what that normally is two systems creating kind of data dumps, and then another system actually reconciling, understanding the internal structures of both of those systems and reconciling what happened and if things happened as they were meant to happen. As you can imagine, this is very, very coupled to both systems, creates a real big coupling point within both systems, and in itself breaks so often that your control, the thing that is meant to control the breaks and actually help you, is the one that breaks even more often. So you end up with this horrible reconciliation processes and still not getting the controls that you need. And to make matters worse, underneath all that, you have often these data warehouses, and normally they are integrating on that lovely pattern known as, database as the integration layer, right? And so you've got these databases and ETLs going from underneath the app, understanding the internals of that app and in terms of its data structures, and pushing stuff into the data warehouse, creating another massive point of coupling, right? And even then, you don't really know if you have the full information because, as I mentioned earlier, things may be lost. They may be sitting in error queues. They may be, you might have breakages because new tables were added or new, and so there is this kind of merry little dance that goes on, trying to just keep up with just keeping these systems going to some extent, right? And again, this is definitely not the way to go. So the architectural pattern is around immobilizing events, right? So what do I mean by immobilizing? Is that what if when the messages were sent, so at the most basic level, when the messages were sent, what if they were kept, right? So like, event sourcing comes to mind, but if more than that, because it's not just one event source, it's many event sources, right? So messages being passed from one to another, the idea is to keep them, to immobilize them. So they're no longer ephemeral. They no longer go away. They are immutable things, facts that happen, and they are there, right? So you can use effectively a public event space or whatever you want to call it, a data plane, or you keep these events, and of course you forward them on to the other systems as you go along. Now, of course, once you are making this decision that all events exchanged outside the system are public, you need to be more careful around their completeness, right? So things like FPML and FIX and these protocols that actually are there and public and are standard are a really good way of keeping these events. But of course, you can create your own ways of governing this as well. And you start creating these immobilized events in space, and other systems start receiving them. What you get is, so you don't have to send acknowledgements and those kind of things, because the next system would do whatever it needs to do and present its outputs or outcomes to the event space as well, right? So you start building this. If you take these bunch of event sources and you kind of take a slice through them, you get a trade life cycle. You have a full view on the trade, and it's real time, and you always have it. It's fact. You're no longer relying on individual systems to be able to keep this truth, this absolute truth that exists, right? And you don't have to start doing controls, point-to-point controls. You can run controls in a holistic manner within this event space, right? So this is the crux of the pattern, right? And of course, there will be many questions in terms of, what happens in terms of, when things change and so on. And there, things like immutability is key, and versioning is key. You don't change anything that's already happened. You add to it, but you can't delete, right? So you keep adding events, but you can't remove what's already there. And of course, you can apply other event sourcing techniques around snapshots and so on to keep things manageable. So moving in, taking that idea forward, you can actually then start thinking about, well, what about actually a shared persistence platform? Because that's what we are doing. You are creating a space that is a shared persistent space where public events are broadcasted and kept, immobilized, right? So then if this is a platform that every application is talking to, it actually starts the beginnings of creating a persistence platform, right? That provides SLAs and provides effectively persistence as a service to other systems, right? And it provides this kind of polyglot persistence that systems may need. So, you know, think of it almost like the way, for example, we use AWS or we use other things, Azure and so on. You know, you go there, there is a service that provides this kind of persistence or this kind of persistence or this kind of persistence, right? And we control who gets to see what, we control the permissions and everything. But it's effectively a multi-tenant persistence platform, right? So you can start moving in that direction. And of course, there are many advantages to that because, you know, you do things once or you kind of outsource that thing so it happens in a really good way, right? Now, I mentioned the word data plane as well, and I just want to clarify some things around the service mesh architecture. So the service mesh architecture, you're probably aware. If you're not, just do a Google search and you get it. But the idea there is a control plane and a data plane. This is an extension of it in a way, because the data plane in service mesh architecture, at least the way they are currently, is more about, one is to make sure that the availability of instances running servicing requests or microservices or whatever you want to call them, they are, or systems, or they are available and they can be serviced. And the other thing is that when one system wants to talk to another system, they have this pattern of sidecar, and a sidecar proxy handles that, handles the SLAs, handles permissions, handles security, all those things to make sure that messages go where they are meant to go. And the control plane actually allows you to configure that and how that happens, right? But this is on top of that. Actually, it's taking that in the service mesh side, which kind of provides a certain platform for compute. It's also about providing a platform for data and for exchanging data, right? So in service mesh, the kind of observability side is on the side, right? Thing is on the side, where we're saying it will be part of the architecture. Okay. So this is the final slide on describing the architecture, but it's going back to this kind of software modernization thing. What we are trying to actually do is create architectural scene, create ways that will make the job of disentangling all this mess that we have easier, and also even within the individual systems, kind of modularizing and even breaking those out easier, so that we have a way of, like, for example, if you have like a source of truth or event source way of representing this data, you know, new systems, new services can come up and start anew and build their own persistence mechanism, and that's kind of more around the event sourcing, the normal thing that it gives you, or that pattern gives you. But what we are trying to do is to create these themes to break out aspects of our system and simplify. And that's it. So now I'll introduce you to Luis, who will describe how Redis fits into this and the different features that it provides, especially around this persistence platform that I was talking about. So Luis, you can.
Thank you, Mosh. Good afternoon, everybody, and thank you for your attendance today. Could you all hear me well? Yes?
Yeah.
Fantastic. So let me take the next 10, 12 minutes to explain how Redis fit in this picture and in this practice. And so we have plenty of time for your questions afterwards. Let me first zoom out and reframe the problem again. Why businesses are trying to modernize the otherwise functional legacy systems? They are essentially to respond faster to demands of business, changes in consumer behavior, and a change in the world. So strangling this legacy system is really the quickest path to value, and this is kind of you know, the why for these architectures, these modernization practices, these patterns. But microservices in general are not a free lunch. This pattern comes with a new set of challenges for developers, for operational teams, for business owners. And so let me focus on three of them and how Redis will help eliminate these challenges and set you up for success in your modernizing initiative. Next slide, Mash, please. So developers will find a new set of problems that they didn't have before. For example, as strangling the monolith with loosely coupled microservices, they'll find out that now these microservices need to talk to each other, exchange and share information, data, messages over the network. So they need to store, buffer this data, these messages, and here's where Redis come to the rescue. Redis, probably most of you know Redis is a cache, but it's also a fast message broker. In our last benchmark, for example, Redis reached 200 million operations per second with latencies consistently under 1 millisecond. Now that will tackle the performance aspect of sharing and exchanging data between microservices of the network, but also Redis provide different data types to make it extremely simple to implement reliable queues, PubSub notification, streaming data, all these kind of patterns that Marsh was mentioning before. So in that regard, Redis could be thought of the super glue of microservices. Next slide, sorry, Marsh. But it doesn't end there. So Redis also helps implement well-known microservices patterns like Saga, CQRS, event sourcing, to name a few. Let's take Saga pattern, for example. The Saga pattern is used when you want to implement transactions that span multiple services, as we discussed earlier with Mash. So in this pattern, each service of the Saga has to perform its own local transaction and publish this event to others. So the other services are listening to that event and capture it and perform the next local transformation or whatever they want to do with that event. So Redis streams, in this case, which is part of the core data structures and functionalities that Redis offers, will make extremely easy to implement this pattern. So in this regard, and if you allow me, in terms of simplicity, Redis is the Apple of databases. Next slide, please, Mash. Now, speed to value is a path to relevant growth for businesses today. In that regard, developers may choose different data models and databases when this makes simpler to implement whatever they're trying to solve. For example, they may choose to use graph databases to make it simpler to build their fraud detection services, or key value to make it simpler to implement their authentication services, or document databases to implement user sessions, just to name a few examples. But this polyglot architecture, this polyglot persistence introduces an enormous operational complexity and requires larger teams, and certainly will increase the cognitive load of the teams. So Redis, as a multi-model database, will provide all these kind of data models under the same umbrella, and will become a feasible alternative to most common uses, to MongoDB, to InfluxDB, to Neo4j, to Kafka, but will provide a single operational model and simplify the complexity of this architecture, let alone the cost around having different databases with different requirements. So in this sense, we can say that Redis is the Swiss Army of databases and will help you decrease the operational burden that microservices architectures come with. Next slide, please. As we mentioned, business owners will be sponsoring new initiatives to adapt to this new world and this fast-changing world. And they will need to do more with less. And this is not an alien concept for Redis Lab. As a business, for the last 7 years, Redis Labs has offered a Redis managed service on the cloud to over 8,000 paying customers and has deployed over 1 million databases over public cloud infrastructure, over AWS, Google Cloud, Microsoft Azure. All this while competing with these public cloud providers that were offering a competing managed service using Redis open source. And that was kind of unfair competition, as they were not contributing back to Redis open source, but anyhow, that's business. So Redis Lab, to survive, had to squeeze every last bit of infrastructure to compete and be able to have a margin on the business. And till this day, we can say that we can save up to 40% over other public cloud providers' bills. Out of these efforts, Redis Enterprise was born, and now customers could deploy Redis Enterprise on the data center or on the public cloud and gain between 30 and 80% cost reduction on the hardware bill, even over Redis open source. And beyond, because Redis clusters need far less resources than other NoSQL databases to implement different features, for example, high availability. So Redis could retrieve all these hardware resources if you already pay for them, and from this rich, hungry alternative, and free them. So free them to other initiatives or prevent business owners to have to pay for new hardware. So in this sense, we can say, if you allow me, Redis is the Robin Hood of databases. Next slide, please. So to sum up, next slide, please. Modernizing your legacy system is the quickest way to value, and it's going to be essential for business relevance and future growth, especially in the post-COVID-19 world. But it comes with challenges. In Codurance and Redis will help you reduce the complexity of these modernization initiatives at different levels, and it will help you decrease application complexity. It will reduce your operational burden. It will reduce the total cost of ownership, and improving your hardware and resource usage. And with the expertise of Codurance and Redis teams, you will be able to increase your chances of success of these modernizing strategies. And that will be it for me. Over to you guys.
Okay, so we've talked about, as Max mentioned before, no, the idea is now to go into a bit of a discussion, no, or Q&A part of the session. We've discussed the problem, or at least a context in which this problem arises. We've discussed a little bit some options for implementation, in particular using Redis Labs, Redis Enterprise, and now, if you have any questions you may want to ask, feel free to use the Q&A section. If not, I will drop something out already to get the conversation started. So guys, if someone is exploring how to start with this kind of solution, where would you recommend they start? Or what are the first things that you think someone looking to implement some of these things needs to look at?
So I can answer that. I think with anything, this is a concept, and you need to prove that concept. Of course, it has worked in other organizations, but every organization is unique. All the systems are unique. The patterns may be the same. So the first thing is to actually create a proof of concept, right? So, but to answer certain questions, right? So some of the questions may be around uh, how do we work with existing point-to-point messages for now, and then try to standardize on them. Right? That could be a question that you can answer. Or how would this perform? How does it work within our current, will it work within our current development processes, right? Or even looking at some of the things that Luis was mentioning around cost, benefits, and those kind of things, is to understand the cost and complexity of the current solutions out there, and how and what kind of savings that this will, and simplicity that this will achieve. So proof of concepts guided by some specific questions that you need to answer are one way to start.
Well, one thing someone had already asked in the chat is, does the solution that we're presenting here applies to, let's say, retail or other verticals?
Absolutely. So yes, it is. All businesses are facing similar challenges in this regard. So they need to adapt to a new world. And some of the services that we're providing were maybe over the counter, or they have a Claire, for example, in the banking that we're offering this, and now they need to switch to mobile or the web to provide the same service. And what they will find is that their legacy system are not ready for this. They're not ready for change fast, but also not ready for a scale, for this new scale that introduced the web or the mobile. And in that regard, if you're starting or you try to start a modernization practice, I will say that start there where will bring you the biggest value in the shortest time, so you can have a quick win, and more business owners and more part of the business will come to you as the expert to help them transform their areas.
Mm-hmm.
Okay.
It's a very, very important point, actually, Luis, is that you need to visualize your whole capability and see where the waste is, where's the biggest waste that you need to solve, right? And use that to then see how this pattern can help. And of course, I totally agree that this is just from the point of view of investment banking, but the same kind of problem exists in any large organization.
We have another question on the chat. It says, is event sourcing a requirement to decouple reporting from isolated systems, or does Redis Stream has that in itself? For example, provide a way to track the events being published and turn them into a reporting view?
This is a really good question. Redis Stream will help you implement this. It would be you have you can think of in terms of a similar model to Kafka, where you will have, for example, consumer groups, and you have different applications that will be able to read for those streams and do things with this. And one of the things could be visualize this, okay? And you can deploy your consumer applications, whether that will be an adapter to a visualization tool that you already have, or you create your own dashboard, for example, or you create your own report out of that.
Okay. So now you mentioned Kafka. What is the difference between, let's say, implementing this solution that we're talking about with Redis Enterprise compared to other solutions like, Kafka?
So if you compare, one is performance. So Redis is an in-memory database in message broker, so it could be 100 times faster than Kafka. It's far simpler to deploy and operate, and cheaper in that regard. And from development point of view, there's some differences that we can get deep. If any of you are interested, we can get deep into this and send you some extra resources so you can play. And we have a couple of block entries where we go and compare and go through with coding examples what could be the difference. But if I have to go down to two things, will be performance and simplicity.
Okay. So we talked about a particular context now, finance, which is a heavily regulated environment. How this solution sort of like tackles, let's say, the mandated industry, security and compliance constraints, let's say, that you would normally find in a sector like this? Like, is there any particulars that need to be taken into account when trying something like this?
I can answer partially this, and of course, in what I can say here is that one of our largest references here in Europe is Deutsche Börse, the German stock market, and they actually have to build a system to address regulator directives, and the bill in particular MiFID II. So they needed to make sure that all the means operations, actually the requirement was to have at least a system that could handle 2 million operations per second. And we exceeded that requirement by far. And they use this to build their compliance, a compliance services, and it went so well, and that they are kind of offering this now to other agents in the market because they have a spare capacity. So they're using Redis as an intelligent cache that is in real time analyzing all these kind of operations and making sure that they are compliant with MiFID II and with what the regulator is telling them to do. So absolutely, and we have examples in this vertical and with large financial institutions that do require these kind of things.
I would add to this, Jose, is that the pattern itself is, in fact, it comes out of the need for regulatory compliance and controls, right? So it's a one aspect of that is, and that's actually within the service measures, the control plane aspect, is that you can decide what goes where, and you always have control and visibility, observability of what's going where, who's kind of consuming what. This is often quite opaque in existing systems. The other thing is controls built on top of that shared space, right? So when things, in terms of reporting SLAs, in terms of trade life cycle and detection, fraud detection, these things, that's what the shared space is for, right? It provides visibility of all the facts that are happening or happened, and so then you can run controls on top of them in real time. So this is again using some certain features of Redis that will allow you to do real-time processing on those things to understand what's happening and stop things as they happen rather than after the fact reporting.
Absolutely.
There's also other features in Redis Enterprise, like access control at the individual even key level in some cases, right? So all those things definitely help with that particular. Okay, so are there any particular lessons learned that you would like to share with today's participants around your experience implementing this kind of solution?
I can tell you this particular architecture point of view. I can tell you there are many lessons. So, and some of them I alluded to, right? As soon as you start sharing stuff, you got to worry about governance, right? You can go too far down the governance route or not enough, right? The other thing is you can you can complicate things. Things can get a bit too granular, right? So you still need to, you can have an explosion of these processes that are taking data and doing stuff. So those are the two things that we really had to worry about. One is to make sure that the way we are choosing to publish this data, initially we didn't have a lot of control in the sense that these events that were coming through, they were custom built internal standards and internal formats and so on. That was okay, but we wanted to get to a point where these standards don't change so often. So we started relying on, where we could, industry standards like FPML, FixML, these kind of things to publish data. And that also ensures completeness. That was the other thing, that sometimes, because you're saying this fact happened, then you start have to worry about the completeness of those events, right? So, and sometimes what was being published was simply not enough. It was just for the point-to-point publications. So you have to start worrying about those things as well. But you can gradually evolve. I would say the lesson we learned and is that not to bite off too much and not to try to make everything so complete. And initially just understand what's getting through the systems and then start moving towards standardization. The other main thing that we had was that there is a lot of data, right? And there's a lot of data coming through. And this is also would be a thing to consider if you are using Redis, right? Is that in Redis, the limit is the memory, right? Not the processing speed, right? The size. And you need to worry about that. So in event sourcing, you got snapshotting and all those things, but you also got eviction from this space and those things you need to worry about, right? So and where do you actually source and what you keep in there and those kind of things. So there are some aspects that would actually add complexity to the solution that you will need to consider carefully.
You mentioned, no, sorry, go ahead.
No, I was going to connect the dots between the previous question and this, and certainly one of the things is that security can be an afterthought, and you have to think on a multi-layer security and compliance approach. And in that sense, Redis Enterprise comes from the experience of having a multi-tenant service with thousands of customers. And so you don't only have to worry about access control, authentication, authorization, encryption, auditing, but also having safeguards for your loads. Let's say that you are going to implement a PSD2, you are getting into open banking, and suddenly one of your services or your API gets quite successful. You get more load, maybe even internal load than you were expecting. And in that regard, Redis is quite good because it has a number of features to prevent buffer overflows, implements CPU throttling, can blocking scripts from accessing the host, and protects from another vulnerabilities that will give you more reliable services. And in terms of scalability, so when I told you that Redis got to 200 million operations per second with latency consistently under 1 millisecond, one of the important things is that was scaling linearly. So we went from 100 millions with 20 servers, small, medium servers, to 40 servers providing those 200 million operations. Having said that, we don't find customer with these large requirements, except for gaming maybe. And as I say, Deutsche Börse was able to provide and have some spare capacity, targeting the 2 million operations per second SLA.
Okay. Right. So then you were mentioning before governance around how we treat data, right? And this already starts moving a little bit out of the technical side of things towards more of the, what are the hurdles of, or the challenges that implementing something like this that usually cross even organizational boundaries, because in the case of finance, some of these areas are, you know, maybe completely different entities, no? And you know, what are some ways in which, you know, they can be tackled, or
Mm-hmm.
do you have any
So,
stories around that?
yeah, I mean, I can start, but Luis can tell you around how Redis would tackle that as well. But the main thing around this, it's not even crossing organizational boundaries outside, because the bank itself is many organizations into one, right? And there are a lot of kind of data locality and data secrecy acts and so on, right? So those, so if you are kind of if you're managing this kind of the way I said, is a persistence platform, then the locality of data has to be part of the platform's capabilities, right? And so you're not trying to, and that should happen at the persistence layer. So rather than each and every application trying to build their own ways of doing things. So, you know, you've got, I've seen many systems in the investment banking world where you kind of have one system talking to another one, but they're crossing this kind of locality boundary, or client sense identifying data, or those kind of things. And then they kind of, that system has information, but this system doesn't need, but the next one does. So that's this kind of weird hopping between systems, and you got the CID information held in a separate place. And so that's all kind of left for applications to manage, and they do it badly, right? So client identifying data and the breaches are, you know, immense, right? And it's something that needs to, that should be fixed once and for all, and should not be left always to the application layer, because certain, you know, data originating from, for example, Switzerland, you know, there's only kind of so much you can share, and those kind of things can be controlled as once rather than by every system individually.
Yeah, so a data layer, I would say that, yeah, this is again a multi-layer approach within the data layer. And Jose, you mentioned before ACLs. Redis makes super easy to do in-memory replication, or to replicate information extremely fast. And on top of that, so you can, for example, replicate the data. There are ways where you can run functions within the database, so you can run functions to anonymize the data, or to extract the data that you don't want. One of the things that Redis streams provide that is different to Kafka that we mentioned before is that Redis implement the log data model, where you put messages in an append only, but one of the functions, of what the difference is, that if you have the rights, you can delete some or remove some of these messages. So you have compliance, or processes or functions even running within Redis saying, okay, that data cannot really cross this boundary, for example. And all that is happening in real time, and without having to move the data and making copies on disk here and there, okay? And there are more things that we can say, but I don't want still time to other questions.
Okay. So, while people are posting the questions on the chat, let's say I wanted to look more into this. Are there any resources that you would recommend that people should go and look into? Yeah.
I mean, there are two kind of, I think Luis can answer for very specific ones, but in terms of the modernization and software modernization itself, kind of taking that holistic view, finding the right places to improve, finding the right patterns, including these ones to improve with. There's plenty of stuff on our website on codurance.com/software modernization, or I think it's services/software modernization. and you'll find a lot in there. And of course, you can contact us directly as well if you have any more specific questions.
Where could people find you guys, Luis and Mash? Twitter?
Yes, you can find us on LinkedIn. You can find us on Twitter. We'll post on the chat of Twitter and LinkedIn accounts, and on my mail as well. So it's very easy, luis.herrera@reslab.com. But I posted on the chat for reference. I was going to mention very quickly, I don't like the title, but we have a booklet called Redis Microservices for Dummies that I think is a really great summary of and with code that you can use to explore a little bit these kind of patterns. And yeah, I don't know if Mash, you want to add something there?
I think from it's hello@codurance.com, or there's the handle, and my handle is @mashuk. So you can always contact me directly as well.
Okay, so we don't have any more questions in the chat. I guess we can then close the session now. Without further ado, let's go back to John.
Cool. Thank you very much.
Thank you. Thank you.
Thank you for
Bye-bye.
having us.
Bye.